link is posted. Got one more lesson to do. Got a lot of people that haven't done it yet. That'll be fun. We're like 30 minutes before the end of the lesson. If you're rewatching this, sorry I didn't start this quiz early like I meant to. I got up and walked away as soon as the lesson was over, and when I came back, I had several messages like, "Hey, when are you gonna start it?" And I was like, "Oh, oops." Talking about lesson 6. Principles and Applications textbook. Can't wait to be done with the day. I got I got plans of staying at home after this. Been thinking about playing around with my audio quality, uh, getting an equalizer and tuning it a little bit. The only problem with that is I don't know anything about audio. I have a few friends that do. Maybe they would pitch in, give me a hand with uh, making this cheapo mic sound a little bit better. I know there's a few software equalizers that I can use in OBS uh, to improve my quality. Because what I hear in the recordings is not what I hear in my ears. I don't know that's a problem everybody has, but I feel like there's a way to improve. I'm going to try. Alright. It's right about that time. So I'm going to leave this up for a minute. Starting now. Leave it up for like 10 seconds so that if you are scrolling through, you can find it. Alright, that's good. Let's go to the quiz. In North America, everything's at 60 hertz. That's how power works. Is everything runs off 60 hertz. Has to do with how fast we spin the generators, or how fast we spun the generators when we were planning everything out. So now everything is at 60 hertz no matter what. And then in Europe, they spun their generators slower, so they have 50 hertz. I say Europe. I assume like the Europe, England area. I don't know exactly what countries do what voltage and current or frequency. Electrical distribution systems shut off devices operate. And it's, Yeah, it's similar to an overcurrent device in electric industrial and commercial operations. All they're doing is shut. It's a fuse. It's basically a fuse. They have more intense things they're dealing with, but it's a fuse. Unless they're meaning those big uh, the big things they have to crank and it spreads apart. But that's basically what's on the inside of a breaker. The most efficient way to send electric power over transmission lines is at the lowest current possible. Trying to close the starting now without putting it up on the screen. Didn't work. So let's make this big. Control A, delete. I just won't save this. Okay. So if you are trying to send a certain amount of power, let's say don't like that. 2400 watts. You could send 240 volts at 10 amps. Would give you 2400 watts. Or you could send 2400 watts. You could send 24,000 volts at 0.1 amps. So if we had a piece of wire, the formula, if we had a piece of wire that was, let's say, 5 ohms. Same piece of wire, same 5 ohms. Well, the formula is P equals I squared times R. That is the power loss formula. We've dealt with it a lot in AC and DC theory. You know what? Let's move that. Put that in the middle. So, 10 squared is 100 times 5. So we're going to lose 500 watts of power if we just sent 240 volts where we wanted it. So 0.1 squared times 5. I am going to use a calculator because I don't. 0.1 squared. So that's going to be 0.01 times 5. That's going to be 0.05 watts. You can see which one is the winner. Now we have drastically increased our voltage, but who cares? It's up way up high and nobody's going to touch it. Hopefully. That's why you don't touch it. But that's quick and dirty napkin math. When power lines are operating at their maximum power load, they can get hot and sag. So that's another thing. If you have... Oh, that is not the right... Somebody sent me a game for my birthday. I was trying it out. Where are we at? There we are. If you have 500 watts being dissipated by the lines versus 0.05 watts being dissipated by the overhead lines, this is going to stay a lot cooler. And it's not going to heat up at all. 500 watts, that might be red hot, depending on how long the wire is. Uh, Watts per foot. Now, if this wire was, you know, 5 ohms, that might be, 5,000 foot long before you get to 5 ohms. So that might not be 500 watts over 5,000 foot. Isn't going to be that big of a heat source, but that's a 110 amp load. You could imagine if you have, a whole street of houses pulling just astronomical amounts of wattage. Like, that's not even 120 amp breaker. A blank is a machine that converts mechanical. Okay, this is a generator. That's simple. All right, utilities normally generate three-phase AC power. Yeah, it's easier for them to generate three-phase and then split that off into single phases for houses than it is to, because some people are going to use the three-phase power, than it is for them to generate single-phase and then also three-phase. They can just generate it all as three-phase, and then some of them are going to be single-phase. All right, let's finish this. I have an alarm set at 5:30. I will come back in here and start up the review quiz, and that's going to stay up for the next 2 weeks. Oh, shoot. Review quiz is going up now. I hit the wrong button. Transformers full review. Every question we've done today is in there. You guys go ahead and do that, or don't do it. I don't care. I will see you guys in 2 weeks. Do your test. In 2 weeks, there will be one test there, and you will have to drop off both of your other tests. All right. I will see you guys. I haven't seen any of you in months, but I'll see you guys in a couple weeks.